Well, I got a white paper from my producer, Gail Tor. Asteroids are coming at us. Asteroids are everywhere. That means that we have to think of Dr. Avi Loeb. And he has written an amazing paper. We're always looking to see what he's up to. We have him on, I think, at least once a year to get an update on anything like the Oumuamua asteroid that came by a few years ago. But this is a really, I don't know if it's an alarmist paper or not. I was just talking to Dr. Loeb about this. But what makes this new object, we'll call it, unique is the fact that it is an interstellar. I guess we're not going to call it a probe until Dr. Loeb identifies it as a probe, but it's very unique. It's got some kind of scary ramifications if it's more than just a hypothesis. And for all the details, guess what? Dr. Avi Loeb is with us. So hey, Avi, welcome to Earth Angels. Great to see you. How you doing?
Thanks for having me. It's a great pleasure.
All right, we got to get to the basics on this. Are you set up at your observatory in Harvard to observe these, or this actually came from another observatory? Is that correct?
Yeah, well, it was actually a half a meter telescope called Atlas in Chile that discovered it on the 1st of July 2025. And then, as it turns out, the neighbor of that telescope is the Rubin Observatory that was just inaugurated a few weeks earlier. And when they looked back at the data from the Rubin Observatory, which is an 8.4-meter telescope, they realized that it was there. Now, it's coming, the reason it was difficult to spot it is because it's coming from the direction of the center of the Milky Way, which is very crowded with lots of stars. And, just this morning, I wrote a new paper about the so-called Lobe Scale. That's after my last name. I proposed an idea a week ago after Congresswoman Anna Paulina Luna called me on the phone and asked me for an update about this new interstellar object called 3I Atlas. 3 because it's the third object spotted by telescopes on Earth is coming from outside the solar system. The first was Oumuamua that you mentioned. Second was Borisov, which was a comet. Oumuamua was very anomalous. We can get into more details. But this one, which is called 3I, I for interstellar, and Atlas for the name of the telescope, she wanted to know more about it, and I told her, in fact, I said that it will come very close to Jupiter in mid-March 2026. And I wrote another paper suggesting that we use Juno, a spacecraft that is currently orbiting Jupiter. We give it a push away from Jupiter in mid-September 2025. It was supposed to plunge into Jupiter's atmosphere in mid-September, the end of the mission. They wanted to kill it, basically turn it to ashes. And I said, don't do that, just push it the other way. And with a sufficient push, it could, in principle, intercept a 3I Atlas. If it doesn't have enough fuel, it will just get closer to it. And even with very little fuel, like less than 10% of the original fuel that it had, it can come within 10 to 25 million kilometers from 3I Atlas and give us more information. Now, why is this information warranted? Why am I speaking about it so much? I wrote maybe by now 26 essays on medium.com over the past month that you can read all the details about. 2 of them this morning. Just this morning, there was a paper from the Hubble Space Telescope that imaged it. And by the way, that's the latest news. There seemed to be a glow of material preceding it. There is no trailing tail. There is no tail of this supposedly comet. So astronomers associated it with just a comet from interstellar space, moving too fast, moving at 60 kilometers per second. Therefore, it's not bound to the sun. It's approaching us. But what I've noticed is the brightness of this object, and I noticed it on the first day when it was discovered. The brightness implies a diameter of 20 kilometers. And, Oumuamua was just about 100 meters, and this one is 20 kilometers. There should be hundreds of thousands of objects like Oumuamua for every object that is 20 kilometers. We haven't seen hundreds of thousands. We've seen Oumuamua, and now this one, after Borisov, which was also a few hundred meters. So that's surprising. And moreover, there is not enough rocky material in interstellar space where it came from to give us an object that is made of rock, which is 20 kilometers in diameter, every decade. In fact, if you just take a census of the rocky material in interstellar space, you would expect such a giant rock, which is twice as large as the asteroid that killed the dinosaurs. You expect that to be delivered to the inner solar system once per 10,000 years. We've detected it over a decade. It's supposed to arrive once per 10,000 years. What's going on here? Of course, one possibility, which I pointed out in my paper, which is now published, is that it was on a directed trajectory, targeting the inner solar system, meaning maybe it's technological, maybe the trajectory was designed. And then with two other collaborators, Adam Hibbert and Adam Crowell, I wrote a paper that is pointing out that the trajectory is indeed really unusual in the sense that it's aligned with the orbital plane of the planets around the sun, okay, to within 5 degrees. And the chances of that happening at random is 1 in 500. That's extremely unusual. And we haven't had 500 objects from interstellar space.
Let me just ask you real quickly, just for as a thought on this latest imaging of this object. Are you suggesting that we're looking at a propulsion system of some kind?
Not necessarily right now. It may have been propelled in the, before it arrived to our vicinity, before we could see it. But the point is that the trajectory is very fine-tuned. First of all, to be in the orbital plane of the planets. That, as I said, that's a 1 in 500 chance of it being so close to the orbital plane. It comes on a retrograde orbit, which is opposite to the motion of the planets around the sun, meaning that if it wants to deploy mini probes that will visit the planets, it's very easy because the planets are moving towards it, so to speak. And then it will arrive very close to Jupiter, Mars, and Venus. And the chance of that happening at random, if you just take that trajectory, you say, okay, I accept it's in the plane of the planets, I just change the arrival time. Still, the chance is 1 in 20,000 that it will arrive so close to Mars, Venus, and Jupiter. And, that makes it unusual. And also it arrives closest to the sun when the Earth is on the opposite side. We won't be able to observe it from Earth. If they know about us, that's the best strategy if they wanted to do a maneuver near the sun, because that's when the gravitational assist of the sun can help do a very significant maneuver. That's what we do with spacecraft. We make a maneuver close to the sun because you are taking advantage of the sun's gravity to propel yourself at a different speed. So if they wanted, for example, to slow down, if they don't show up on the other side of the sun after we can't see them during the month of October 2025, they will pass closest to the sun on October 29th. If they don't show up on the other side as expected, I think the stock market may crash.
Oh my God. Amazing.
Now, I should also say that this morning I wrote a paper. It's also available on medium.com, where I suggested it already a week ago, but I now elaborated on that, of what is being called the Lobe Scale, which is a risk scale for interstellar objects coming from outside the solar system. 0 implies that it's a natural object, a rock, like, for example, an asteroid or an icy rock, like a comet, the type of rocks that we are familiar with in the solar system. And, that would be a 0 because, the chance of that hitting the Earth is very small. It really needs to be on a straight trajectory towards Earth, and that's a very small probability. But 10 on that scale is definitely artificial in origin, definitely technological, meaning that we can see maneuvering in a way, non-gravitational acceleration that represents perhaps propulsion or some engine. We see evidence for artificial lights or excess heat from an engine, or we see an unusual shape of the object. All of these are indicative of a technological signature. And, I think it's important for us to scale any incoming interstellar object on this scale. And now the Rubin Observatory in Chile will start discovering every few months a new interstellar object. Until now, we had only 3 spotted by telescopes over the past 8 years. But from now on, there is an increase by almost 2 orders of magnitude in the detection rate, and therefore we should be alert because the implications will be huge to humanity, not only in terms of us understanding that there might be a smarter kid on the block, us being able to learn from their technologies, but also there is a threat. There is an existential threat to humanity. And in the past, we worried about the existential threat from artificial intelligence or from climate change. Lots of people are talking about these all the time. And every now and then, we also talk about the threat from a killer asteroid of the type that killed the dinosaurs. And of course, NASA was tasked by Congress, the US Congress, to look for all objects above the size of a football field that may come close to Earth. And that's the reason the Rubin Observatory was constructed. But I'm saying there is another type of objects that we should be worried about, and we don't discuss those. And that is alien technology objects. And we should just check each and every object entering the solar system. If it has anomalies that put it high above, I would say above level 4 on the Lobe scale that I propose, we should definitely have policymakers discuss them, getting more data from scientists and deciding how to respond to them. And then, of course, psychologists to decide how to communicate the message to the public without creating panic, without economic meltdown.
Yeah. Have you been able to determine the shape? Is it like the Oumuamua asteroid, which looks aerodynamic to me, but do we have an idea?
So Oumuamua changed its brightness every 8 hours as it was tumbling by a factor of 10. And the best fit for the variation of reflected sunlight from it implied that it has a disc-like shape, very unusual. And moreover, it was pushed away from the sun by some mysterious force. And there wasn't any evaporation that is visible, no cometary tail whatsoever, no molecules of dust or carbon-based molecules that are usually accompanying any comet. So there was no rocket effect acting on it. The question was, what is pushing it? What's creating this non-gravitational acceleration? And unfortunately, we are left in the dark about it because we didn't get enough data to figure out its nature. And I said, look, these anomalies should alert us because it may be just like our own space debris, the space trash we put out. For example, 3 years later, the same telescope in Hawaii, Pan-STARRS, that discovered Oumuamua as a near-Earth object, found another near-Earth object that was pushed by reflecting sunlight. And that one ended up being a rocket booster from a 1966 launch by NASA. And just on January 2nd this year, 2025, the Minor Planet Center reported about a new asteroid near Earth. And then they realized, oh, wait a minute, this one moves along the path of the Tesla Roadster car that was launched by SpaceX. And then they removed it from their list. So this one was not a rock. It was a car, okay? And all I'm saying is that maybe Elon Musk is not the most accomplished space entrepreneur since the Big Bang. 13.8 billion years passed since the Big Bang. The sun formed just in the last 1/3 of cosmic history. Most of the stars formed billions of years before the sun. And you can ask, where will Voyager be in a billion years? It will be on the other side of the Milky Way galaxy. And therefore, there was plenty of time for their space artifacts to arrive to our backyard. So we should simply be agnostic and check each and every interstellar object whether it has some technological features.
Can you tell with your equipment if an object is changing its trajectory as it's coming from an interstellar location?
Definitely. You can, in fact, with the help of the Webb telescope, which is positioned 1.5 million kilometers away from Earth, we can look at the object from 2 directions, from telescopes on Earth and from the Webb telescope. It's just like having 2 eyes that allow us to gauge distances of objects. And in fact, I believe the Webb Observatory is actually looking at it today. Okay, so we shall see. But the point of that is not only the Webb telescope is able to help us pinpoint the trajectory of the object and figure out if it has non-gravitational acceleration to a very high precision. We didn't have that with Oumuamua. we had just the Hubble Space Telescope, which is much closer to Earth. The Webb is farther. We can get the position of 3i Atlas much better. But moreover, the Webb telescope can detect the heat emitted by 3i Atlas. In other words, not just the reflection of sunlight from it, but the infrared radiation that it emits. And that can help us figure out its surface temperature, to figure out its surface area. And then as it spins every 16 hours, we could actually sort of get a three-dimensional mapping of how it looks like, and I'm waiting to see what the results will show. It's, science is exciting because you don't need to know the answer in advance, despite what my colleagues are, they always know the answer in advance, like it must be a comet, and then they get surprised. So in this case, just to give you the surprise of the morning, there was the first paper analyzing images from the Hubble Space Telescope taken on the 4th of July, 2025. And they show a glow of something in front of the object. In front, not behind. Usually with comets, you have a tail. That's why we say cometary tail. It's behind. This time, you see some glow in front of it, in the direction that it moves towards the sun. And the question is why? Of course, one possibility is that it's only, it doesn't spin very rapidly, so it has a hot day side and a cold night side, and the day side is warmed up by the sunlight, and therefore, it ejects dust particles that you see in front of it and not behind it. But another thing that is peculiar is there is no evidence, and by now there are maybe 5 independent papers from different observatories using some of the best observatories in the world that took a spectrum of the object, looking for the characteristic, molecules that accompany cometary activity. These are carbon-based molecules that you find in every comet in the solar system, and they haven't found any spectral. They only saw reddening of the reflected sunlight. In other words, the object is red, but doesn't show evidence for gas, molecules, or atoms around it. And that's puzzling.
That's fascinating. In your paper, you have considerations to support your hypothesis that this is artificial. And one of the things I wanted to ask you about, you say it's too large to be an asteroid.
Right.
And that makes, what does that mean? If Oumuamua was Oumuamua too large to be an asteroid too?
No. Oumuamua was roughly 100 meters inside. I mean, that was the length. It could have been very thin, actually. But this one is 200 times bigger. It's 20 kilometers in diameter if what we are seeing as its brightness is simply reflection from a solid object, okay? Now, of course, it's possible that some cloud of dust around it is doing the reflection. It's not the object. But if it is the object, then it's 20 kilometers in diameter. And why is that puzzling? Because there is not enough mass in rocks in interstellar space to deliver a 20-kilometer rock to our vicinity every decade. Our survey went on for a decade. You can do that once per 10,000 years. That would be reasonable, but not every decade. So either it is a comet, but the nucleus of the comet is very small, less than about a kilometer in diameter. Then you don't need a lot of mass. And then the reflection that we see, the brightness of the object, results from dust that was evaporating from the small object that creates this glow around it. Has nothing to do with the size of the object. The size of the object is very small. That's one possibility. And of course, if it happens to be a large object, I think it's extremely puzzling. Why are we seeing it in over a survey of 1 decade? And the one possibility that can explain it is because it's not on a random trajectory. It's not like, you have a lot of these rocks moving around. It's actually an object that targeted the inner solar system by design. The trajectory wanted to get to the inner part of the solar system to visit the planets in the habitable zone. And that, of course, would suggest some designed trajectory, some intelligence behind the trajectory, which is also indicated by the fact that it's in the ecliptic plane where the planets move around the sun with a probability of 1 in 500.
Is it possible that this came from the same civilization that sent out the Oumuamua
It's possible.
object? Is it in that in the
I
general?
mean, it comes from a different direction, but we don't know the nature of Oumuamua. It could be just a surface layer, some debris left over. I mean, I should say that this object, 3I Atlas, entered the outskirts of the solar system, the edge of the Oort cloud at 100,000 times the Earth-Sun separation about 8,000 years ago, if it started from far out. So 8,000 years ago, when humans started recording history, that's when this object was at 100,000 times the Earth-Sun separation. On the other hand, you can imagine some kind of a base of, alien technologies within the solar system, like they already are not so far. Like if they are at 1,000 Earth-Sun separation, 1,000 times that, it would take them only about 80 years to reach us, and so if they see that we are developing as a young technological civilization, we are developing and posing a potential threat to them, they might visit us. And, that is the dark forest hypothesis, which was a solution to Fermi's paradox. Enrico Fermi in 1950 had lunch in Los Alamos and they were discussing extraterrestrials. And he asked, where is everybody? And one possible solution is that they are out there, but they are silent because of worries about predators. That's a better strategy for them to survive. And if they see a young civilization like ours developing technologies that are on the cusp of endangering them, they might do a reconnaissance mission to visit us. We should be aware of that possibility because we don't know who exists in our cosmic neighborhood. We see a lot of sun-like stars, 100 billion of them in the Milky Way galaxy. Most of them formed billions of years before the sun. And we assess that, billions of Earth-Sun analogs may exist in the Milky Way. Okay, so billions of them. And, you can argue, and that's what my colleagues in academia keep arguing, that it's an extraordinary claim to imagine that these houses that look just like ours on the cosmic street have no residents or never had residents. And I'm saying, how do you know that? Let's check. Let's assume, what is called the Copernican principle, that we are not special, which implies that, if we are not special, things like us existed billions of years ago. And we just need to search. And, the simplest way to search is not look for radio signals from these houses towards us because, nobody may call us when we are listening. Actually, the best way is to check our backyard and see whether among the rocks that we find there might be a tennis ball that was thrown by a neighbor. Mm-hmm. And that is exactly what I'm suggesting to do with interstellar objects.
Let me just change the venue a little bit. In your most recent dredging of the Pacific Ocean for that downed object that you thought may have been artificial, did you pull up any analysis of it being an exotic metal?
Well, we had the expedition cost about $1.5 million. With that budget, we could only use a sled that was covered with magnets that we placed on the ocean floor. Right. And we couldn't really see what we are picking up. There was no live video feed. So we brought up some magnetic particles, molten droplets, from presumably an explosion that came from a meteor. And then I brought back about 850 of them to Harvard University, where I gave them to my colleague, Stein Jacobson, a world-renowned geochemist that has the best instruments in the world. And we analyzed those materials and found that about 10% of those spherules, molten droplets, have a chemical composition that is different from solar system materials. It was never reported before in the scientific literature. But I really want to get bigger pieces. These were small. The spherules were less than a millimeter in size, and there isn't a lot of material in them. And I want to go back to that location and search for bigger pieces in the wreckage of the original meteorite, and perhaps even find the core of the meteorite. But to do that, we need to use a remotely operated vehicle, ROV, robot, with a video feed. That would cost $6.5 million, and we don't have the funding as of yet. If we do get the funding, we'll go there again.
That's fascinating. Is it your hypothesis, Dr. Loeb, that we are being observed and these are just probes? I mean, that was what we were talking about last time. This is more dire. And I don't want to get to the consequences right yet, but I do want to get your sense of what we're dealing with. If this is a 500,000-year-old civilization that perhaps is not around anymore, these are perhaps probes that are looking for signs of life.
Well, it's possible. We don't know their agenda. We don't know what their intent is. We are a young technological civilization with only a history of 100 years since quantum mechanics was discovered. I mean, the two of us are speaking thanks to our understanding of quantum mechanics. The instruments we're using are all based on quantum mechanics. And only 100 years, 1 century elapsed since we started understanding physical reality in the context of quantum mechanics. If you have another civilization that is far more advanced, they might even be more intelligent than we are. The human brain might not be the pinnacle of creation. There might be, smarter kids on our block, and that means that we won't fully understand. Even if they didn't have much more time to develop things, they could have developed things much better than we did. Just look at the world politics. We are not that intelligent, But the other thing I wanted to mention is that so far we launched probes to interstellar space. These are Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, New Horizons. And they will become trash they will not be functional once they leave the outskirts of the solar system in the Oort cloud, because that would be 10,000 years from now, and they were not designed to survive that long. But another civilization that is far more advanced could have launched functional devices, and they might visit us, for a purpose. And I think, just like with any blind date, my advice for young people that are on a blind date is to first observe before having an opinion about the visitor. I mean, a lot of people prefer to attribute whatever they see to scripts of science fiction writers or from Hollywood. And I say all of these scripts are just like large language models of artificial intelligence, in the sense that they are based on some training data set, that whatever is familiar to us, the experiences we had on Earth. LLMs are not smarter than us because they are trained on what we see, and what we see is limited to Earth. Okay, that's it. But whatever comes from another star is, could be out of this world. It's all bets are off, and therefore we should be open-minded to be surprised, instead of claiming anything in the sky must be rocks, the way my colleagues that are comet experts keep doing. I call it the Stone Age of space exploration, in the sense that anything in the sky must be stones.
Yeah. Oh my God. Do you have a feeling of this object being a UAP, or is it more of just a probe?
Well, that's interesting because, it depends on the size. But if it's a 20-kilometer object, by the way, very similar to the dimensions of Rama in the science fiction novel Rendezvous with Rama that Arthur C. Clarke wrote about.
Right.
He also envisioned a cylinder that is 20 kilometers wide and 50 kilometers long. But if this object 3I Atlas is so big, you could imagine that, it would take a huge amount of energy for it to maneuver and visit planets. It might actually just deploy mini probes that go to the planets, sort of like a mothership. In that case, those mini probes would result in enhanced activity of unidentified anomalous phenomena on Earth after the visit. So that will be October 29th, 2025. And if we see more anomalies in the sky on Earth, they may be related to smaller probes that have not, that are not the original object, but they were deposited. And the Galileo Project, under my leadership, is currently assembling 2 additional observatories. We have one functioning in Massachusetts, monitoring the sky in the infrared, visible light radio and audio, and we analyze the data with machine learning software to figure out if there is anything unfamiliar in the sky. And we are assembling additional observatories, one in Pennsylvania and the other one in Nevada. And they should be ready by September 2025. And that's a month before 3i Atlas comes closest to the sun. And we will be able to tell if there are any objects, anomalous objects that produce enhanced activity relative to what we see regularly. I mean, we have the ability to detect a few million objects every year with our instruments. And the one special thing about these observatories is that they are not traditional astronomical observatories, because those are limited to a very small region of the sky. Usually astronomers are focusing on a small part of the sky at any given time, whereas the one that we constructed from scratch is a new type of observatories where we monitor the entire sky at all times, and we pay attention to objects that move fast overhead. These are the kind of objects that astronomical telescopes often ignore. And I really look forward to future data. I believe, as a scientist, I really enjoy having as much data as possible. I was asked on a podcast, how do you tell the difference between a genuine scientist and a conspiracy theorist? And I said, there is a very simple way of telling the difference. If you just deliver much more data from instruments, the scientist will be delighted, even if it changes the mind of the scientist. Many times in history, scientists change their mind based on better data. That is exactly the scientific method. You have some conjecture, and then you test it with data. And if the data doesn't agree with the conjecture, it's ruled out. Okay, that's a detective story. That's the way scientists operate. However, a conspiracy theorist will be upset by more data. That conspiracy theorist will say, don't give me the data, don't confuse me with facts. I know the answer. And how dare you even study those facts?
All right, so let's get to the conclusion of this paper. And this is so unlike the Avi Loeb that I am familiar with, but the dire consequences are that this is potentially coming for Earth, and that we need to be thinking of defense measures in some capacity. So this is something that I've always had a chill up my back about, because we really don't have any known anti-asteroid defense system. But maybe it could be clandestine, a black ops project that we don't know about.
No.
But why are your conclusions like that, Avi? Is it because it's in the path of Earth's orbit?
No, it's not coming close to Earth on its current path. In fact, it gets closest to the sun when the Earth is on the opposite side. But that's the point where it can do a maneuver. It's called an Oberth maneuver, taking advantage of the sun's gravity. And perhaps it doesn't want us to see it. For example, it could release mini probes that are doing this maneuver, and it will be hidden behind the sun. So I'm just worried about it. We should see. It might be just a natural comet, and then we don't have to worry about it. That's the nature of getting as much data as possible about it so that we can figure it out. The reason I put it out as a possibility is to encourage my colleagues, observers, to get as much data as possible, because when you have a lot of data, it's impossible to shove anomalies under the carpet of traditional thinking. Just consider Galileo Galilei. The church put him in house arrest because they didn't like the answer he provided by looking through his telescope. But if, on the other hand, they would have looked through telescopes and said, we would demonstrate that Galileo Galilei is wrong by looking through telescopes, collecting more data about Jupiter, and showing that he was wrong, then they would have corrected course much faster. I mean, it took them 350 years after his death to admit that he was right. And I say they could have saved this time. They could have decided within a few years that he's right by looking through telescopes. And so if I can encourage my colleagues to prove me wrong by looking through telescope, we'll get data. If I am actually wrong and it's just a comet, natural object, so be it. Okay, we learned it's a natural object. That's it, case closed. But I don't want us to miss the opportunity to get all this data by being relaxed and saying, we know the answer in advance, it must be a comet, stop talking about it, how dare you speak about something else. This is not an intelligent approach to science.
In this paper that you write, Are you in contact with the Department of Defense, who would probably be the ones who would direct a missile towards trying to avert?
No, I should say that right now the trajectory of 3I Atlas is such that there is no way that we can reach it with any rocket to intercept it as it comes to the sun, because it will be moving at 98 kilometers per second in the opposite direction, relative to Earth. And we just, our best rockets are move at a third of that speed. I mean, we can intercept it much farther out, but not as it approaches the sun. There is no way right now. And the other comment I wanted to make is that you can see that also as an opportunity, because if we happen to have an alien technological threat, I think it will bring people together, because we would realize that we are all in the same boat. And, we will perhaps stop fighting over territories on this rock that we were born on, the Earth, because there is much more real estate out there. And we are very limited in our mindset, of zero-sum games on this Earth. But if we see some other threat coming beyond, this Earth, then perhaps we'll realize that we are all in the same boat. Let's work together. And in a way, it's the messianic message of peace, like perhaps we need a messiah from another star.
Avi, I love this material. I have to say this, it's so refreshing to have your transparent point of view, because other scientists would not be so free in the data. And perhaps this is the big problem with UAPs, is the fact that here they are, they're observing us, but no one's really taking it serious. I think in your paper, you say it's important to take it serious because this could be a dire threat.
Yeah, definitely. I mean, we should allow for this possibility. We should not ridicule it. If you want to refute it, if you want to show that it's wrong, instead of expressing your opinion, look through telescopes, collect data, and show that it's wrong. This is my request to the critics. It's not enough to just blog on it or write on it on social media. I was criticized over the past few weeks by people who are not practicing science. Just check their record. They don't have a single scientific paper over the past decade. And they criticize me, a practicing scientist. I wrote 9 scientific papers in the month of July 2025. Just over the past 30 days, I wrote 9 scientific papers. They didn't write a single one over the past decade. Yeah. And they're protecting science against practicing scientists. How dare they?
Yeah.
I mean, this is really ridiculous. Obviously, they just want to get clicks, but their opinions should not matter, because science should be guided by evidence. And my point is, science should not censor questions. Any question should be allowed, okay? The question of whether it's technological should be allowed. The scientific method is not about which questions to avoid. It's about using data, evidence to answer these questions, okay? So, is it technological? Get data and show that it's not. But don't express your opinion and move on. That's not the scientific method.
Are you, and we're closing here, are you anticipating alien contact at some time in our lifetime?
Well, it all depends if they're out there, and I'm trying to find out. Obviously, by saying they don't exist and saying that it's an extraordinary claim, you're entering a self-fulfilling prophecy, because you're not seeking the evidence. And in that case, you will obviously maintain your ignorance. It's just like you look down without looking up, or you act like the Vatican that didn't want to look through Galileo's telescope. So did that change the reality of the situation? The Earth was moving around the sun for 4.5, billion years before the church even existed, and it continued to move around the sun even after they put Galileo in house arrest. It doesn't change whether we have neighbors or not if we ridicule this. The question is, can we find out scientifically if that's the case? And for that, we need to collect data. And my point is, let's just be agnostic and not ridicule ideas. Let's try to test them, by finding as much data as possible.
Fantastic. 3I Atlas is a fascinating thought. Where do we take it from here? Are we going to watch it as it leaves our cosmos, or what?
Well, it's in the coming months, it's getting closer to the sun. So by October 1st, we won't be able to observe it because it will be too close to the sun. And the sun will basically burn up any telescope looking there. But it will come closest to the sun on October 29th. And after that, during the month of November and December, we should be able to observe it as long as it continues along the expected path, by the way. And we will learn a lot about it in the coming 2 months. And I expect us to know more about its nature. And that's the way science is done, that my opinion will change as more data comes in. But even if it turns out to be just a natural comet, I say we should examine each and every new interstellar object that the Rubin Observatory discovers every few months over the next decade. So it's a completely new reality that we never had before, where we are now on the path to discovering every few months a new interstellar object, and let's just be open-minded and check each and every one, whether it's a rock or something else.
Fantastic. Avi, wonderful being with you. Thank you for this, and always an eye-opener when I have you on the program. Always something fantastic. So, hey, continued success on this, and we'll. Is this a part of a book you're working on? I would think there's a book coming.
Right now, I'm working on a book about the expedition to the Pacific Ocean. There will also be a Netflix documentary coming out in early 2026 that includes footage from the expedition. So stay tuned. And there are lots of other exciting developments that I cannot speak about right now, but my life is interesting. We didn't have time to discuss it. There are lots of other interesting things going on.
Where can people read more about your work? Do you have a space website that they can check?
Yeah, well, every day or two, I post an essay on medium.com. So just search for Avi Loeb, Loeb, at medium.com. And you can subscribe for free to my essays for email notifications. Every time an update comes along, you will get it.
I fully expect you to be the one who's going to make the first contact with an alien race.
Well, I already, I was asked in one of the podcasts whether I'm seeking a Nobel Prize. And I said, I said, not at all, because if we discover some alien intelligence, a technological artifact near Earth, I just will not waste my time going to Stockholm to get, some recognition from a committee. Instead, I would like to dedicate the time to exploring this encounter. And I will basically follow Bob Dylan on that front and not acknowledge the prize.
Fantastic. Hey, I really appreciate your time. Thanks for being with us.
Thanks for having me.